Hello everyone. In our previous video, we have seen copying the files inside the container, working on those files at different stages of the container lifecycle. Let us assume we have an application. We have this particular application which is running inside this container. This application, let me call it as application 01. This application is triggering some logging files. So there is some log files which has been triggered by this application, which is getting stored in the root of the file system. So root of the application directory. So this is my application directory where all the logging, let us say this is the logging directory where all the logs are captured. What will happen to these files, whatever the application is capturing? These files will persist even if I stop the container. If I stop the container, restart the container, these files will be available. If I delete the container, then these files will not be available. So basically, whatever the data which is being written by the application, everything will be written at the writable container layer. So this is okay. The application is able to write the data to the container file system. But what will happen to the files which are written by the application, whether the data persists or not? There are some of the drawbacks. Let us see those drawbacks by using this approach. Containers are non-persistent. It does not store any data within its file system. So basically container storage is temporary. We will not be able to recover any data once the containers are deleted. All the data will be destroyed. Container storage is coupled to the underlying host machine. Whatever data which is being written by the application, everything will be written to the host layer. So we will be able to connect to the container to copy the data from host to the container or container to the host. Every time we have to connect back and forth to copy the data from container to host or host to the container. And container storage drives are less performant. If my application is running on a container, let us say this container name is container 1 C1 and this is my application 1. If this application has to write some data to the container, this container, there is an additional layer which is created. This is an abstraction layer. For the container to write the data, there is a driver which will be used by the container. So this driver will be similar to our display driver or sound driver, which the container uses to write the data to the host storage. So this is my storage layer on the host. It uses the driver to write the data to the storage. So this is less performant because we use extra abstraction layer to communicate to the storage layer instead of writing the files directly to the host file system. The data which is stored, it can be application data, user data, or log data, will be available till the time the container is up and running. Once the container is deleted, the data will be destroyed. There will be no data at all. So, how do we persist the data? There are two options to persist the data in Docker. We can use either volumes or bind mounts. We'll be able to use volumes and bind mounts to persist the data. Let us understand what is volume. A volume is stored on the host file system at a specific folder location. Choose a folder where you know the data won't be modified by non-Docker processes. The default directory where Docker stores all the volumes whatever we have created will be slash var slash lib docker and volumes. So this is the default directory where all the volumes whatever we are created, everything will be stored under this directory. We'll be able to use docker file to use the volumes straight away as an instruction. So we can use volumes as an instruction inside the Docker file. Docker creates the volume if it doesn't exist. When we pass the instruction inside the Docker file, if the volume doesn't exist, it is going to be created. Volumes are stored within the directories on the host file system. So this is the host file system. Volumes will be created and stored inside this directory. Docker mounts and manages the volume in the container, whether we are going to explicitly mention as an instruction in the Docker file, or if we use the command when we run the CLI, Docker is going to manage the volumes. After mounting, these volumes are isolated from the host machine. Whatever volumes we are created, these volumes are isolated from the host machine. Multiple containers can simultaneously use the volumes. If we have created a volume, let us say if I have created my wall and container 1 is accessing this particular volume, container I can make container 2 also to access the volume. Either I can pass the instruction inside the Docker file, or I can use the CLI command to run the command to use this particular volume to both the containers. This is important. Volume also don't get removed automatically when a container stops using the volume. So this is the advantage. When I stop the container, when I delete the container, whatever volumes I have created, whatever volume I have created, this will remain as it is. So the data, whatever the container 1 and 2 has written to this volume, which is my underscore volume, it will persist. So this is the advantage why we use volumes. Ultimately, our main goal is also to make the data persist even if the containers are deleted. Even if these two containers are deleted, our main goal is to persist the data whatever the container has written to the volumes. There are third party companies who provide plugins, like they can provide cloud storage plugin to add those plugin to make use of the cloud storage. It can be Azure, it can be AWS, or it can be Google. So we will be able to use the plugin to connect to their storage. Let us understand the volumes with some comparison. I have the Hyper-V. So this is my Hyper-V. This is type 1 virtualization software, and we also have VMware. This is also type 1 hypervisor. Whenever we wanted to install operating system or store any data, what we do is basically we create a disk. This disk, whatever we are going to create, this is called as VHD file or VHDX file. Here in VMware, it is called as VMDK file. So this is basically a file what we are going to create, and we specify it as 60 GB or 100 GB or 1 TB, and we attach to the virtual machine. This file is acting as a volume to the virtual machine. So basically, this is a file whatever we are using inside the virtual machine of the hypervisor, which is Hyper-V hypervisor. In VMware also, we create the virtual machine. If I wanted to create a disk, we create VMDK disk attached to the virtual machine. It can be 60 GB or it can be 100 GB. So whatever size I wanted to mention, I will just specify the disk size. I will attach the disk, which is nothing but a file which will be stored in the data store. So basically, when I create a volume in Docker, which is my underscore volume, this is similar to the file whatever I am going to create in Hyper-V environment or VMware environment. It is similar to VHD file or VMDK file to store my data to persist. Even if the container is deleted, I will be able to access the data. Let us see what is bind mount. A bind mount is conceptually the same as volumes. However, instead of using a specific folder, you can mount any file or folder on the host. So whenever we create the volume in Docker, if I create my vol, it is going to be stored inside var lib docker and volumes. Let us say I have the host. This is my Linux host, and I have the file system. There are file system like opt in the Linux, right? usr, opt, mount, mnt, and data. If I wanted to mount any file system to the container, I'll be able to create a file system and then mount to the container. So under data, if I wanted to, let us say, if I create a folder bind mount, I don't want to use this particular file structure within the host to create the volume. I can easily mount any of the file system within the host operating system. So if I wanted to mount slash data slash bind mount, I can simply mount this particular file system. Volumes are considered the preferred data storage strategy to use with the containers. In this example, whatever we have mounted, right, this particular file system, what we have mounted from the host file system, we'll be able to mount two different containers. This will be C0, C1, C2. We'll be able to mount the same file system to multiple containers. If I have to create a volume, I have to use this particular command, docker volume create and volume name. I can list the docker volumes, docker ls volume, not this, docker volume ls. And if I want to inspect the volume, docker inspect and the volume name. So this volume is created. If I wanted to use this particular volume within the container, what I have to do is, if I am going to create a container using the volume, then I have to specify this particular command, docker run dash v. So this is, I am saying that I am going to use volume. Either it can be bind mount or it can be volume. If I am using the volume, then whatever volume I have created. So this is my volume, what I have created here. So this volume I am going to use here, and where exactly I wanted to mount. I wanted to mount to the application and then the regular command syntax, whatever you wanted to use it for the image to create the container. So let us say I wanted to use 5000 for the port, and this is for my web application, and name of the container web01, and the name of the image node app. So this is my custom image. Using this custom image, I am going to create this container, and I am using the volume whichever I have created. This is on my local host, and this is the container location where this particular volume will be mounted. D is in detached mode to run the container in background, and P is to expose the port. This is for the host port, this is for the container port, and this is my name of the container, and this is the image. So this is the custom image from which I am going to create this container web01. Similarly, if I take the same example to use for bind mount, then I have to use this particular command, docker run, and I can actually explicitly mention in Docker file as well. Instead of running this command in the CLI, I can make this volume as an instruction when I create an image, when I build an image using the Docker file. Docker run -v. So this is the same flag which I am going to use for volume and for the bind mount as well. Then I need to specify the host path. So this is my host path. So data bind mount. So this folder which I have created, this I am mounting to the container. I will mount to the /mnt on the container, and this will be /mnt under data. I am going to mount, and then I'll run in detached mode. I wanted to expose the port 5000 with the container port 80, name web02, and I'm going to use the same image to build the container, which is my custom image, node app01. This is my image name. So this is the command for bind mount. This is the command for volume. To use the volume, you need to create the volume, but to use the bind mount, whatever directory what we have created under the host file system, we are going to use the explicit path of the folder location or directory location and mount to the container. So this way we will be able to persist the data using volumes and bind mount in Docker. Thank you for watching the video. If you like the content, please subscribe and share the video. Thank you and take care.